Hi, good afternoon, everyone. So today we are going to go ahead and take ISI PEA 2007, question 11 to 15. Let's read out the question. So it says, consider the function, you're given the function as x square and 4x cube plus 7. Then is it 1-to-1 or not, and so on and so forth. So this is very, very simple question. So clearly, if you can just go ahead and look into the second function first. So try to look into the... Actually, let's start with the first one only. So we're given fx is x square. So we clearly know that when I talk about x square, this is how I plot the function, right? So whether I take negative value of x or positive value of x, I am going to the same value of y, right? So this is typically not a one-to-one function. This is an onto function, right? So f1 is 1-to-1 is absolutely incorrect. Okay, and f1 and f2 both are 1-to-1 is also becoming incorrect, right? Now I just have to check for the second function, right? So if I look into the second function, what do I go ahead and get? So if I find out f dash x in this case, so I'm going to get 12x square, right? Which is strictly positive. You put any value of x, you will get f dash x as strictly positive. So because this is strictly positive, we are very clear that this is a strictly increasing function because f dash x is positive. And if it is an increasing function, then each value of x corresponds to one value of y, right? So it becomes a one-to-one and an onto function also, right? And therefore, we can go ahead and we can say that this is a one-to-one and onto function, and the right answer would be C. Okay, come to the next question. Okay, question number 12. So this says fx is given to you as, let's write it down somewhere. So fx is given to me as a plus x upon b plus x to the power a plus b plus 2x. Right. So you need to go ahead and you need to find f dash 0. Okay, so let's find out. So what I will do is let me just take this as y. And now let me just go ahead and take log y, right? So if I just find out log y, it is going to be log a plus b upon, sorry, a plus x upon b plus x to the power a plus b plus 2x. And now what we can go ahead and do is, so log y will be, I will take a plus b plus 2x out. It is going to be log a plus x upon b plus x, right? So now what we can go ahead and do is log y will be a plus b plus 2x log a plus x minus log b plus x. Now let's differentiate. So 1 by y dy by dx is equal to differentiation of first function into second as it is. Into differentiation of the second function into first as it is. Now we need to evaluate dy by dx at x equal to 0. So because when I will be finding dy by dx, there will be this y component that you will be seeing here, right? So you will be noticing that there will be this y component that will be coming here when you will be evaluating dy by dx. So what you can go ahead and what you can therefore do is just plug x as 0, right? So if I just find out x at 0 here, the value of y, I will be getting a plus 0 upon b plus 0 to the power a plus b plus 2 into 0. So this is going to be a by b to the power a plus b, right? So what I can go ahead and do is, instead of y, I will be putting a by b to the power a plus b, right? And then here I will be getting 2. So if I just plug 0 here and 0 here, I will be getting log a minus log b plus. If I just put 0, I will get 1 by a minus 1 by b into a plus b into a plus b, right? So now I will be getting a upon b to the power a plus b 2 log a by b, log m minus log n, plus b minus a upon ab into a plus b. So b minus a, b plus a will be b square minus a square upon ab, and this is going to be 2 log a by b, and this is going to be a by b to the power a plus b. And that would be the answer to this question. So if I try to find the answer in this case, it is going to be B, right? Okay, come to the next question now. So it says, this is a typical linear programming question. And, sometimes I would like to just highlight in linear programming question, instead of going ahead and instead of trying to solve the question, because here it is not asking you whether it is at which value you achieve a maxima or minima. So if it does not ask you at what value you go ahead and you achieve a maxima or minima, what you can go ahead and you can rather do is you can just try to use the graphical approach. You just have to tell if there is going to be infinite solution, unique solution, corner solution, or no solution. So that can be something which I can easily do through the graphical approach. So what I'm going to go ahead and do is, so you need to understand here that the slope of this function, if I find dy by dx here, it is going to be minus 1, right? So I can just take this as x plus y is equal to 6. So dx plus dy is equal to 0. So dy will be minus dx. So dy by dx will be minus 1, right? So if I just plot this function, I will have 6 here and 6 here, but its slope will be minus 1. If I look into the next function, then I have 3x plus y is equal to 15. So 3 dx plus dy will be 0. So I will get 3 dx is equal to minus dy. So dy by dx will come out to be minus 3, right? And then I can just plot this also. This is x, this is y. So when I go ahead and I take y as 0, x will be 5. And when I take x as 0, y will be 15. And I can just go ahead and mark this here, right? And notice that its slope is going to be minus 3. Now let's go ahead with the third function. So the third function that has been given to me is x plus 3y is equal to 15. So if I take dx plus 3 dy, this will be 0. So dy by dx will come out to be minus 1 by 3. And then you can also plot this. Here you will have 15, and when you will put x at 0, y will be 5. Here you will be having 5, and you can just join this thing, right? Of course, this may not meet in the way that I have just, kind of drawn it. It will be something like this. So, the region that you will be seeing will be from here to here, to here, to here, right? So this will be your common region that you will be seeing. Now, what happens in this case is, let's go ahead and let's take some value of this function, the function that I want to go ahead and want to maximize, right? So the function that I have in hand here, that function is 0.5x, that means 5 by 10x plus 15 by 10y, right? This is the function that I have in hand. Now let's take some random value of this function. Say I take this to be 1, right? So you can understand first of all that if I were to find the slope of this function, what will be the slope, beta? So 0.5 dx plus 1.5 dy will be 0. And then I will get dy by dx is equal to minus 1 by 3. So my slope will come down as minus 1 by 3. That will be my slope, first of all, right? Now also try to understand that suppose I take it equal to 1. So if I put y as 0, what will be x, beta? X will be 2. And if I take x as 0, what will be y, beta? Y will be 2 by 3. And this will be my curve. This will be my function. Now, this is just one of the level curves of this function. I can take, instead of 1, I can take 2, I can take 3 and so on, but there will be these parallel lines that you will be seeing. So what will happen is, I need to see where this function gets maximum. So I can just go to the highest value possible. And that actually happens where it coincides with this function. Because I need to evaluate it in this region. Try to understand this thing. If I just zoom it, I need to evaluate it in this region, right? And my function gets the highest value at all these points, right? So this has infinitely many solutions. Also, what you could have gone ahead and you could have done is through the mathematical approach. Like you could have solved the 4 equations, get these points. And then you will also notice the same thing that from 0, 5, that point, 0, 5, that means from this point till this intersection point, all of them give you the same value of the function, which is 7.5 and the highest value of the function. So even through the numerical approach, you will get that there are infinitely many solutions to this problem, right? Okay. Now come to the next one. So this says, let this function be given to you, and you're given that f of x theta is equal to theta f of x1 plus 1 minus theta f of x0. Okay. Where theta is between 0 and 1. Okay. Now this goes ahead and it says further both f of x1 and fx0 are PDF functions. Then what happens? Okay. So try to understand that f of x1 is a PDF function between theta 0 to 1. So if it is a PDF function, it means that when I will go ahead and I will integrate that function, then I should get the answer as 1. Right? Similarly, if f of x0 is a PDF function, when I will be integrating that, then also I should get the answer as 1. So what I have gone ahead and I have done is, I am saying that so this is a new function that I have created. I am just putting an integration here and an integration here and integration here. This is a constant. This just comes out of integration. And let's say I just integrate it from wherever it is defined, from minus infinity to infinity. But this is a valid PDF, so it should give me the answer as 1. Now, this minus infinity to infinity can be anything. It can be from any A to B. But the general way we write it is minus infinity to infinity. This is also a valid PDF. So this will also go ahead and give me the answer as 1. Right? So I will get theta into 1 plus 1 minus theta. That means I will get the answer as 1. So that means when this is integrated, I'm getting the answer as 1. So this also becomes a valid PDF. Right? So the answer will be A. It's a valid PDF for all values of theta. Okay, come to the next question. It goes ahead and it says, you are given that, so you need to find out the correlation R for the 5 pair of observations. You're just given some values of X and Y. So X is given to you as 5, 1, 4, 3, 2. And Y is given to you as 0, 4, 2, 0, minus 1. There is nothing that I can explain in this question. This is pretty simple. I have just used its formula. So the formula is summation xy upon summation xi square, summation yi square in the deviation formats under root. So you're just given this data point. I'm leaving it up to you. I'm just putting it, I'm just showing it to you. So the mean value of x that I've got is 3. So here you can just go ahead and find x minus 3, call it as small xi. The mean value of y that I've got is 5. So here you can just go and have yi minus 5. Yi minus 5, call it small yi. And then you can just do xi into yi. And then you can just do xi squares. And you can just do yi square and just find out its under root after summing them up. Right. So when you will go ahead and put it in the formula, you will get the answer as minus 5 by 4 root 10. I think this is not an ISI level question. This is a very simple correlation question and there is nothing to be solved here. So I'm leaving it to you to be solved. This is the formula that you can go ahead and use. Okay, thank you.